This is lecture number 16. In this video, we are going to discuss about inverse Laplace transformation of derivatives. Okay. So before we start, please subscribe the channel. And if you want to follow me, then follow me. This is Insta ID. So you can follow me on Insta, right? Also Lakhyajit 123. Okay. Now, before we start, please subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded. And if you like my videos, please hit the thumbs up button. So now let's start. So inverse Laplace transformation of derivatives. Okay, so why do we need this? We're going to discuss this later when I'm going to take an example from Lakhyajit's book. I will take a question, from Lakhyajit's book, mathematical physics book. So before that, let me explain the theory here first. So if the inverse Laplace transformation of f of s is f of t, right? This is function of t. Then, inverse Laplace transformation of derivative of f of s. Derivative of f of s is given by minus t into inverse Laplace transformation of f of s. Inverse Laplace transformation of f of s, and inverse Laplace transformation of f of s means this is nothing but f of t, right? F of t. So let me write this properly, f of t. So now you see it can be written as f of t f of t is equal to f of t means what I have said, inverse Laplace transformation of f of s, right? So this is going to be equal to, this f of t will be equal to, from this equation, this minus t will be here, right? So that is 1 by minus t, or minus 1 by t into inverse Laplace transformation of dds of f of s. So now, why do we need this? Why do we need this? Because you see, sometimes we may have some function f of s, if you check all the formula that if you can't find any suitable formula to find the inverse Laplace transformation of this function, then we use to differentiate this function, right? Then we're going to use this. Suppose, let me take a question, then you're going to understand better. Okay, so first let me copy the formula that we're going to use here to solve such problems. Just wait. Here you see. Now let me, suppose we need to find the inverse Laplace transformation of this function. Here you see. So you if you check all the formula that related to Laplace transformation and inverse Laplace transformation, so you can't find any formula that it can transform directly log of this, right? So here we're going to use this concept, right? So first what we're going to do, just let me write the given function first. So f of s is log of 1 plus omega square s square. This question is taken from the book Lakhyajit's Mathematical Physics by Lakhyajit. So here you see. Okay, first let us differentiate this dds of f of s. That's going to be equal to, if you differentiate this, then what you're going to have, before that, let me do one more thing. Let me simplify this log function first. So this can be written as s square plus omega square by s square. So here we're going to consider s as variable and omega as constant. Here omega is constant term, s is variable. Okay, so now here, and if you apply the property of log m divided by log n, that is log m by n is log m minus log n. Okay, if we use that property, then we can write this as log of s square plus omega square minus log of s square, right? We can write that way. Now let us differentiate this dds of f of s. So if you differentiate this function, then what you're going to have, then you're going to have 1 by s square plus omega square. Again, you need to differentiate this function within bracket s square plus omega square, because this is function of function, right? And log of this is 1 by this one. Then again you have to differentiate this, right? So that is what we have got. Now if you differentiate this, then what you're going to have 2s, right? So we can write, let me cut this one, this is 2s by s square plus omega. Similarly, minus, if you differentiate this, then you're going to have 1 by s square, then again into 2s. And if you cancel s and s square, then what you're going to have, then you're going to have, let me write here, 2s by s square plus omega square minus, so s cancels s square, then 2 by s. That's what we're going to have, right? So now if we need to find the inverse Laplace transformation of this f of s, that is ft, right? Then we are going to apply this formula, so which is equal to minus 1 by t inverse Laplace transformation of dds of f of s, right? So now we know the derivative of f of s, but we don't know the inverse Laplace transformation of this. So let's find the inverse Laplace transformation of this derivative, right? So inverse Laplace transformation, just let me copy the last two lines and let me go to a new slide. Okay, just wait. Okay, so here you see, so in order to find the inverse Laplace transformation of this, we need to know inverse Laplace transformation of derivative of f of s. Okay, so inverse Laplace transformation of dds of f of s, that's going to be equal to inverse Laplace transformation is of this. So 2 can be taken out, it is constant. Inverse Laplace transformation of s by s square plus omega square, and minus 2 inverse Laplace transformation of s, 1 by s, right? 1 by s. So 2 into inverse Laplace transformation of s by s square plus omega square. See, inverse Laplace transformation of s by s square plus a square, that is cos at. Why? Because Laplace transformation of cos at, Laplace transformation of cos at is s by s square plus a square. Now instead of a we have omega here, so that is the only difference. So it gonna be cos omega t, and 2 into, then we know that Laplace transformation of t is 1 by s. So inverse Laplace transformation of so let me write it, inverse Laplace transformation of 1 by s, that's gonna be t, right? So here it will be t. Inverse Laplace transformation of 1 by s is t. So now let me cut these things. So now you see, let us use this value here. So we're going to use this value, which is derivative inverse Laplace transformation of derivative of f of s. So we're going to use this value here. Okay, so if you do that, then what you're going to have, you're going to have minus 1 by t, and we have got inverse Laplace transformation of this is 2 cos omega t minus 2t. That's what we have got, right? So then if you multiply minus 1 by t with this one and this one as well, then this result is, then this result gonna be equal to minus 2 cos omega t by t, and minus minus plus, and if you multiply with this one, t will be cancelled, right? Then you're gonna have only 2. here. So that's going to be the result, right? So now you see, so this is our answer. So inverse Laplace transformation of f of s, that means, so what was the f of s in this case? Inverse Laplace transformation of the f of s is this. Here you see, this is the f of s, this function, right? So here we're going to write log of 1 plus omega square by s square. So inverse Laplace transformation of this function is this one. So this is our answer. So hope you have understood this. So if you enjoyed the video, please share with your friends, help me to grow my channel, inspire me to create new contents for you, and stay connected for new contents. Thank you for watching. Bye bye.